Now we've begun. Now remember, anything you say after this point can and will be held against you in a court of law. Oh wait, that's a different starting. You do not have the right to an attorney, I'm sorry. Yeah, this is a bad courtroom review. Bad courtroom review. I read part of the John Grisham novel, but I didn't finish. Like I didn't get all the rules. Alright, so we're talking about validity. Now, validity, when we're talking about an argument, we're going to take a step back. We did our exam yesterday, we're all now back into skill factors. But now let's go back into reasoning. So how we think through problems, how we make a proof, what constitutes a proof. We discussed how inductive reasoning versus deductive reasoning. Inductive where we're just using examples, like numerical examples. Deductive where we're kind of showing the general case. A proof needs to be a deductive thing, something that can be shown for all cases. Oftentimes the way we understand things is inductively. We see evidence, we understand something from what we've seen in the past, we build from what we've learned. So I could tell you that 1 more than an even number is always an odd number, but I don't know that because of the proof. I know that because 2 plus 1 is 3, and 6 plus 1 is 7, and 438,714 plus 1 is also an odd number, right? All of these we can see, kind of from just what we've seen. But to do the proof, we would need to show that with the general case. Now, sometimes we can deal with proof that is fallacious, something that has a fallacy in it. So we're going to use a very famous fallacy here. We're going to prove this, and we'll explain how this works. So the proof that 2 equals 1. So far, let's see. Let's say A is equal to B, right? Just A something is equal to B something. So A plus A should be equal to A plus B, right? Because A is equal to B. So far, seems good. We added an A to each side. And now we're just combining like terms. Right? Because A plus A is 2A. And then, okay, what if we now subtract 2B from each side? And if I do it to one side, I have to do it to the other, right? 2A minus 2B. So I better go A plus B minus 2B. I've done the same thing here as I did there. Okay, still fine, it seems like. Okay, now I'm going to, I'm going to say 2A minus 2B. I can factor out a 2 from both of those. So this I'm just simplifying. Right, on this case we factored that out and we were left with A minus B. On this side, A plus B minus 2B. B minus 2B, that's just negative 1B. Okay, so A minus B, yeah, that's good. Reasonable, pretty simplified. Now, we have another interesting thing. What if we divide each side by A minus B? So I have 2 A minus B's divided by A minus B. Okay, so I'm just going to divide by and now I'm going to simplify. So I've done this. I've realized that when I divide 2 times A minus B divided by A minus B, it's equal to A minus B divided by A minus B. Well, A minus B divided by A minus B is equal to 1. And 2 of A minus B divided by A minus B is equal to 2. So I've just proven, beyond the shadow of a doubt, that in all cases, 2 is equal to 1. Right? That's what I just proved. No. Right, that's what I did. I proved that 2 is equal to 1. I just broke the world, didn't I?
What? So like $2. So we put this into like reality.
That makes $2 equal $1.
You could destroy inflation.
Okay. So let's think through this. There is a humongous issue here. Obviously, 2 is not equal to 1. If I give you $1, will you give me $2? Well, you might because you're really high. So you probably shouldn't do that over time. Okay? Not the best. Monetary decision. So where is the error? There is an error somewhere here. I'll give you a hint. The error comes from this initial fact that A is equal to B. Let's think about somewhere in this math that if A is equal to B, this causes us problems. Maybe think about, is there something in math that if you do it, you break the world? Maybe break the world is a stretch, but is there something where if you do it, you suddenly approach infinity? You suddenly have an undefined value? What do you guys think? Do you have any thoughts about where an error may have made? Maybe there's something that doesn't really exist, something that can't be done?
Question for? I think it's correct.
Yeah, so then you bring it home, you don't change it. Yeah.
Like,
It's a good guess.
two variables can't be.
Why not?
Because they would have to be the same variable.
Well, my bank account is equal to your bank account. We both have $1 in our bank account. So Boyce's bank account equals Jed's bank account equals $1. Two variables equal the same thing. Nice. Yeah? Another great guess, but no. I'll give you a hint. There's one operation, hey Jihan, let me check it out there. Do you want to put that on my desk? If you divide by 0, we end up with pretty big mathematical problems. Do you guys know what something divided by 0 is?
Zero.
No, it's
Just the
one.
number.
It's one.
Let's think about this instead. Let's think about this. By the way, that just means you all failed math 3 or math 4. But let's think. What if I go, okay, Salman, what's your favorite number?
6.
Okay, 6 divided by what? Okay, nice. Good. Okay, you passed math 3 again now. How about 6 divided by 0.1?
Is there something lower?
No, it's not something lower. If it was 6 times 0.1, it would be 0.6. But it's 6 divided by 0.1. It ends up being 60. Nice. 6 multiplied by 10. Okay, how about 6 divided by 0.01? Okay. How about this? 6 divided by 0.0000000001.
Big add number.
1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 with 9 zeros after it. 6 billion.
Easy.
Now, let's just imagine this. As we go to smaller and smaller numbers. So what about 6 divided by 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000. Some really, really small number. Can you see how the resulting answer would be getting extremely large? We actually say if 6 is divided by 0, it's approaching infinity, right? It's undefined at such a large number. You can't divide by 0 now because you're approaching infinity, right? If you were to like graph this, if you were to graph 6 divided by x as it approaches 0, you would have an asymptote at the y-axis because this number would get so large. Hey.
But if you divide 6 into 0 groups, you're putting 6 in that would mean the number.
It would be everything in there.
If you divide, Troy's asking a question. So if you divide 6, the number 6, into groups of 0, you have that 6. You're trying to divide this into groups of 0. You open an infinitely large amount of groups because you can't put anything in each group. Right? If we divided 6 into groups of, say, 0.001, there's like lots of groups of groups of 0.001 to make up that 6. These groups are smaller. The whole point is this. Dividing by 0 causes us big problems in math. And that's the issue in this group. Didn't we define initially that A was equal to B? Yes. Okay, that seems important. Is there any situation here where what we've defined will make it so we divide by 0? Oh. What is something minus the same thing?
0.
So A minus B is 0. So in step 6, right? In step 6, we divide by 0. And if you're actually, Jaden's kind of asking the next question, well, wait, but the one we divide by 0, the other we started at 2. Well, is 2 zeros or 1 0 equal to more? There's no value for 0. There's nothing. Doesn't matter. Yeah, it doesn't matter if it's 0 here. And similarly, this is 2 undefined or 2 0 divided by undefined. Right? This is a mathematical concept. We're into the realm of something we cannot be. The reason we have an issue here is because you're dealing with 2 or 1 zeros divided by infinity. It's meaningless. That's what's happened here. So we've set up a meaningless group. And this is actually kind of where we're going today. So That was an invalid proof.
Please hold back. Can we not go?
Didn't I just tell you? Think through it. The issue was in step 6. We divided by 0. Issue is in step 6. We divided by 0. So, this is a invalid proof. The issue wasn't with one of the premises initially. It was fine for A to be equal to B. But there was a logical issue that happened partway through it. Yeah. So it's invalid because step 6 wasn't correct. It's correct to divide both sides of the equation by the same quantity, except that quantity in this case was 0. Right?
Okay.
So all the other steps are correct, but one improper action makes the proof invalid. Now, an argument is when one or more statements come together to make a conclusion. An argument may be valid or invalid. So that one was invalid. And though this is beyond what we need for the curriculum, there is truth or non-truth, which is based on the content, whether what's in it is true or not. And then validity is based on the logical form. All that means is something can be valid but untrue, right? We can have something where the arguments are sound, but it's not true. Let's think of an example. If I said that premise 1 is that all students are taking math 20-2, and then, argument 2 is all students who take math 20-2 love pizza, therefore all students love pizza. These premises, may be logically coherent. What I said is coherent, but the statement wasn't true. Not all students are taking math 20-2. Actually, also not all students love pizza, because some people are evil. So you can see how in that case, the truth of the argument didn't fit with its how logical it was. And we'll look at some of these other things. Also, whether it's sound or not, I'm going to leave that, whether an argument is valid or not. If you want to take the LSAT or the SAT, this is a concept that will matter very much. This point will because we'll kind of hint at it. So let's look at these arguments. All women are mortal, argument 1. Anne Irwin Young is a woman. Therefore, Anne Irwin Young is mortal. So, argument 1, all women are mortal. Anne Irwin Young is a woman. So, women mortal, this person a woman, therefore mortal. Okay? Next one. Some people who cough out the flu. Jaden has a cough. Therefore, Jaden has the flu. Is there an error in one?
No.
Why?
It's not all. Yeah.
Excellent. Very, very loosey-goosey. What's the error? So argument 2 has a big issue. Wink, wink. Good thing to notice.
It's actually great because I have a cough, I don't have to do.
Ah, nice. There we go. Proof in the pudding. What? Instead, he has COVID. Thanks for sharing that, Jade. We appreciate it.
Yeah, I was really sick.
How about this? This is a fairly famous story. It's been used for lots of different settings. I've actually mostly just seen it with like a hotel, but we'll talk about Comic-Con. So some of our fellow X-Men fans are going to San Diego Comic-Con. 3 of them. They get a ticket to the convention center, room and board at the convention. They travel from Lethbridge to San Diego. Wow, that's a pretty good drive. They arrive a day before it's to start. Late at night. They need 1 extra night stay at the hotel. It's not included in the package. So they come to the hotel. The hotel has 1 room left, but it's still under renovation. The manager gives them a discount because the room is not completed and they're attending the Comic-Con. And the manager charges them $30 for the room. Oh, good deal. So they contribute $10 each. So far, this seems reasonable, eh? 3 friends, $10 each, $30 for cool. The next morning, the manager rethinks the rate and decides to give them a further discount. Whoa, further discount, cool. In the hopes they will book again for next year. He gives the bellboy $5 to take to the room to give back to the 3 friends. So they paid $30, $10 each. The bellboy brings $5 back. This devious bellboy realizes the 3 friends are not expecting any kind of refund. It will be too difficult for the 3 friends to split $5 evenly. 1.6 you're going to think, yeah, good luck. He decides simply to give back $3 and keeps $2 for himself, right? $1. So he gives the 3 friends the $3 refund. Each of them gets $1. They had originally paid $10, but each of them received $1 back. Okay. Now they've only paid $9 each. So far we seem good, right? They're happy the manager's giving them a further discount. They'll come back to the same hotel next year. And the bellboy is happy. He has $2 extra in his pocket. So Bill is thinking about this. He calculates the total cost. He sees that $9 per person times 3 people, plus the $2 the bellboy kept is $29. But didn't they pay $30? What happened here? $9 per person times 3 people. So that's right, hey? They each paid $9, and so $27. And then the bellboy kept $2, so they only paid $29. Where's that extra dollar? It's in someone's pocket. It was lost in the laundry. No, mathematically there's an issue here, right? Clearly something's up here. Now, this is one of those, this is almost like a magician's trick, right? Clearly, we've shown you something, and we've said, aha, but there's something happening here. Some little mix-up. Yeah, exactly. Something disappeared. Now, the $1 hasn't disappeared. This is a perfectly reasonable story. But this setup is a trap. Does anyone think they see through the trap? It might be worth thinking through what operations we're doing here. Is it reasonable to go $9 per person times 3 people? That seems reasonable to me. And did they then add $2 to the bellboy? No, they didn't. The bellboy took $2. So in that case, then, if we have $9 per person times 3 people, $27 minus the $2 the bellboy kept, aha, is $25, which is actually what was paid. Okay, there's the issue. We were trying to get it back to this $30 that was what was originally paid, but no, they ended up paying $25, not $30. So it's $27 initially, and then $2 that he kept. That's where the $25 are. They each paid $27, or they each paid $9, and then the bellboy kept $2. It's $25.
Oh, it never says 30.
Well, $30 is what they had paid initially, right? But then that would be made up by the $3 extra per person plus the $2 the bellboy kept. But what we're adding up to here is actually the money that was paid total at the end. Okay. Yeah. Nah. That's what we're doing. Yeah.
Yeah, it was fun, but I was like, Bill just
Here's the beef. We get trapped by the way we've set this up and thinking, oh, this needs to add up to $30. What adds up to $30 is 3 times 10. Right, 3 times 10. And if we want to make that up from the story at the end, well then it would be 3 times 10 minus the $3 that each person was refunded and minus the $2 that Bill was, or that the bellboy kept. But instead, what we have with this setup is the amount that was paid is $27 by them, but the bellboy kept 2 of those dollars, so the hotel only got $25. Right? That's what this is actually setting up. Which is like, it's a flawed argument to the premise for your reason. So, today, here's what you're going to do. And a hint for your exam. Well, I mean, I don't know if you look at this. A hint for your exam. There will be one fallacious proof on your exam where you have to figure out what the issue is. I've usually found that's the question that people struggle the most with on this exam. Probably like 40% of you will fully get it right or something like that would be what I've seen. So it's worth trying to practice how you can figure out where a fallacy is in an argument, what's reasonable.
It'd be a really long text.
It won't be this long, no. It won't be this long, no. Then we'll work through. Actually, there's one I was thinking you didn't have to do. Why don't I just give you the list of the questions that I had said initially, and I'll let you guys just work. Questions for today. 1, 4, 5, 6, 7, 8. So 1 and then 4, 6. So you don't have to make a fallacious proof. Basically. 1, 4, 8.
Oh, okay.
Oh,
I see what I said.
Can you go for me while you're there?
Alberta's tired.
And my hope is that you guys want to homework today. I think this is reasonable to do in class.
How could it
And in a bit, I can do question one for you if you want. Although the answer is at the back, so you can look at it if you need. This is a